Assalamu alaikum, a very good morning dear students, and welcome back to your physics class. And this is your physics teacher from United Public School. So students, in our today's session we are going to learn about the second important principle, that is the AFBO principle. Actually we have three important rules, or we can also say it as three important principle. Under that, firstly, that is the first one is the Pauli exclusion principle, which we have already completed in our last session. And the second one is AFBO principle, which we are going to learn in our today's session. And third one is Hunt's rule. Okay, so let's start our today's class with the second principle, that is the AFBO principle. So the word AFBO is German word. The word means building up. So the building up of orbital means the filling up of orbitals with electrons. So here building up of orbitals, in the sense we need to fill up the electrons in an orbit. So actually these principles state as electrons first occupy the lowest energy orbital available to them and then enter into the higher energy orbital only after the lower energy orbital are filled, which means electrons will be filled firstly in lower energy orbital, then move towards the higher energy orbital, as we do if we want to build any building. See here, if you want to build any building, so you will start construction doing from top to the bottom or from bottom to the top. Yes, from the bottom then to the top. We need a strong base. After basing in the top, in the bottom, then only we will slowly move towards the top. In this similar manner, we have to fill the electrons in an atom from lower energy level then to the higher energy level. So here, which is lower? The orbital which is closer to the nucleus is the lower energy level, which means this orbital is the lower energy level. This lower energy level is also called as ground state, and the orbital which is far away from the nucleus is the higher energy level. So this is our higher energy level, which is also called as excited state. So we will firstly fill electrons in ground state, then slowly we will move towards excited state. So this principle state us this thing. See students, in your textbook they have given a ascending order, a particular ascending order of energies, that is 1s, 2s, 2p, 3s, 3p. It is in ascending order. To make you easy, I draw a table. See, first column indicate orbitals, the name of the orbital, that is 1s, 2s, 2p, 3s, 3p, 4s, 4d, 3d, 4p. So these names I have already told you in our last class. Over here, when I am explaining you about the relationship between n and l in second quantum number, at that time I told you the energy level names 1s, 2s, 2p, 3s, 3d, right? So that names I have written over here, orbital names, then value of n, then value of l, then I have added the value of n plus l, which means I need to add both of these values. Then orbital energy level. So here we are going to find out the orbital energy level by the help of these values. So firstly 1s in the sense, actually here ns, it is actually ns. In place of n we have written 1, in place of n we have written 2, in place of n we have written here 2, 3, like that I have written like this. So here which is n? This is the n. So value of n is actually 1. Next, value of l. How we are going to find out this value of L? Remember students, I told you. So this is the energy level S, P, D and F. So you have to write this in your rough page if you are not understanding. So 0, 1, 2, 3. S indicate 0, P indicate 1, D indicate 2, F indicate 3. So here we need to value of L from S. S we have 0. So the value of L is 0. Next, 2s. Here n value is 2 and s value is 0. Next we have 2p. So n value is 2, p value is, see here, 1. So I have written 1 over here. So like that you need to take the values of n and l. Then you have to add both of them. 1 plus 0, 1. 2 plus 0, 2. 2 plus 1, 3. 3 plus 0, 3. 3 plus 1, 4. Like that we get the value of n plus l. But what is the need of this n plus l values? See here, the energy level. 1s, we have 1 electron, then 1s square 1. 1s 1. Then here we have 2, 2s 2. 3, 2p 3. Here 3, 2s, but we can't write here 3 because this 2s orbital always carry only 2 electrons, not more than 2, but less than 2 it can carry. So here we can write 2, but here before that 2s we have 1. 3 it becomes. So like that you need to find out the orbital energy level. Then see this diagram, student. It is very important diagram, the figure number 6, that is filling order of atomic orbital. So here we have written n values. N values started from 1 to 8. Then L values started from L is equals to 0, 1, 2, 3. Only 3 values we have, right? So 1s from here, 1s, 2s, 3s, 4s. This 1s value from 1 to 8 we have written. Then in L, first column will be lost. Okay, second 2p, 3p, 4p, 5p. In ascending order 2, 3, 4, 5, 6, 7. Then it is a p. Next we have L value. Actually this L0 indicate S, L1 indicate P, this L2 indicate D, this indicate F, isn't it? So we have taken 1S, 2S, 3S, 4S, like that. So next here we need to leave it as it is, in it empty. Then 2P, 3P, 4P, like that you have to take from value here, then here, from here, from here. See, in the similar manner here we have to leave out two columns. Then 3D, 4D, 5D. In the similar manner here we have leave one column, then two columns, then 3 columns we have left. Then here 4F, 5F. In this manner we have to take this diagram. But actually it starts from like this. As you can see, we have arrow mark. We have started from S, 1S, 2S, then 2P, 3S, then 3P, 4S, then moving like this only 3D, 4P, 5S, then 4D, 5P, 6S. Like that we will have to move in a particular manner. This is a particular manner. These energy values only we have written over here. So now let's find out the electronic configuration of some any elements. That is, we have firstly hydrogen. Hydrogen atomic number is, atomic number indicates Z, represents Z. So atomic number of hydrogen we have 1. So only 1s, 1. These 1 indicate electrons. We have only 1 electron, isn't it? So we need to fill up in the box only 1 electrons. 1 arrow indicate 1 electron, as I said in our last session. In the similar manner we have taken helium. Helium atomic number is 2, which means 1s2. We have 2 electrons. So 2 electrons we need to fill up in the box. So 1 arrow, 2 arrow, right? Actually but in a single box we can fill only 2 electrons, which means 2 arrows, not more than 2. Okay, we can write 1, but we can't write 3. Like that, similarly we have taken lithium, which have atomic number 3. So this atomic number 3 can be written as 1s2, 2s1. 1 plus 2, 3. 1, 2, 3. Next, beryllium 4. 1s2, 2s2. 2 plus this power you need to observe. 2 plus 2, it becomes 4. So 1, 2, 3, 4 arrows, which indicate 4 electrons. Similar manner, boron, which have 5. 1s2, 2s2, 2p1. 1, 2, 2. 2 plus 2 plus 1, 5. 1, 2, 3, 4, 5 electrons we have filled. Okay, actually in S only we can fill up 2 electrons, and in P we can fill up 6 electrons, in D we can fill up 10 electrons, in F we can fill up 4 electrons. I told you this in our last class. So in S not more than 2, less than 1 2 we can fill. In P not more than 6, less than 6 we can fill up. Similar manner we have written here, see 1s2 2s2, we can write 3 also now. No, because S carries only 2, not more than 2, so that we have taken 2p1 again. Okay, so it is very important, don't forget this. See here, they have asked a question for carbon 6 3, they have 6 atomic number. Where does the electrons go? So let's write over here C which is carbon, so it has Z, means atomic number which is 6. So how we can write this? 1s2 2s2 2p, yes 2p2. So now let's fill up these boxes. You should not draw randomly boxes. First 2 boxes should be separated, and then third box should have 3 columns. Okay, so which means this first box indicate S or S, and second box indicate again S, third box indicate P, then we have another box in your future, that is D, that will have 10 columns. Actually this was based on this only. As we told, S carries only 2 electrons, so S means 2 electrons in one box. P has 6 electrons, these P 1 2 3 4 5 6. Then D have 10 means we need to add 5 boxes. Like that they have given boxes, so here we need to fill up 6 electrons. 1 2 3 4 5 6. Like that you have to add the electrons. Like that arrow also you can use, and like this which I have written, you can also use this kind of arrows also. So by this we have completed our second rule. It was quite confusing. Don't get confused. If not understand, then watch this video again. So students, your today's assignment is in your textbook applications. Under that you have third question, that is the following orbital diagram shows the electronic configuration of nitrogen atom. So here we have to find out the configuration of nitrogen N2. Which rules does not support it? That is nitrogen had Z is equals to electronic configuration, that is 7. So you need to write this question and answer in your notes and submit in your group. While writing, be focused, don't do silly mistakes, students. Okay, thank you. Have a nice day.